besides the recumbent leg. He's the only thing
Now we are videoing, so even though you're welcome to go get your food, whatever food over there you want, you're welcome to go get it. And thank you very much for your donations. Happy Pi Day, I'm sure. Have a great day. But now we need to get back to our vectors. So we are on the first page, page 49. Yesterday we got through the first two, but we have a lot more to go. So let's do that. Part 3A says here's point P and here's point Q. Let's see what we remember from what we learned. Yep, was it yesterday? Yep. Yep. Let's see what we remember. We need, first of all, the components or the coordinates of PQ. Now, we learned how to do that. We're talking about the vector from P to Q, right? Now, we know how to do that. How do we find the coordinates of the vector from P to Q? 3 to 4 is 1, and 1 to 2 is 1. Those are the coordinates of the vector from P to Q. Now, the new, let's review. The new piece of it is, what is the magnitude? So the notation we're going to use for magnitude is the absolute value bars. So from now on, when you see the absolute value bars, and if you turn the page, you'll see some in part 4, that always means magnitude. And you guys in physics know that magnitude is just vector language for length. Some branches of mathematics have their own language. Remember how in the unit we just finished, we didn't talk about coefficients, we talked about scalars. That's just a different vocabulary for that branch. Well, in vector land, they have scalars in vector land also, but they also don't say length, they say magnitude. Magnitude means length, and it's super simple to find. I want you to think about the vector that goes right 1 and up 1. That vector looks like this. It goes right 1 and up 1. That's what that notation means. It goes 1 this way and 1 this way. So, how long is it? If it goes over 1 and up 1, what would be its length?
1.
No, it's not 1 and it's not 2. What kind of triangle is that?
45.
I know, well, okay, it is 45, 45, but I don't need to know that. I do later, but not right now. That's over 1, up 1. If the legs are 1, what's the hypotenuse?
2.
Root 2. You can do the Pythagorean theorem, kids. It's a right triangle.
Need a refresher on
A squared plus B squared equals C squared. Okay? So 1 squared plus 1 squared equals C squared. 1 plus 1 equals C squared. 2 equals C squared, and C equals the square root of 2. So the magnitude of the vector is root 2. Now, let's do the same thing with the next one. All right, so step 1, find the components or the coordinates. What are the coordinates of the vector from P to Q? Well, 7, 1. Is that okay with everybody? From -1 to 6. Think about your number line. -1 to 6 is 7 steps. -1 to 0 is 1, 1 to 6 is 6, okay? Now, here we go. If I drew the vector that goes over 7 up 1, how long would it be? What is its magnitude if it goes over 7 up 1? We'll do the Pythagorean theorem. 7 squared plus 1 squared. So that's going to be the square root of 50. 49 plus 1. And now I reduce that. The square root of 50 would be 5 root 2. Because 50 is 25 times 2, and the square root of 25 is 5. So it's 5 root 2. That's our magnitude. All right, let's see if you can do the next one on your own. At least figure out. At least figure out the components. So don't say it yet. Just stay still. Think it in your head. Write it down. What are the coordinates of the vector from P to Q? Janae?
Okay, so this is a dumb question, but I just forgot. The a squared plus b squared equals c squared thing.
That thing is called the Pythagorean theorem.
Yeah. So the sides are the a and the b.
Yep.
And hypotenuse are c.
Always.
Okay. That was my question.
Always. All right. What did anybody get the coordinates of PQ? 7 and a negative 5, and that is exactly correct. This is the vector that goes forward 7 and down 5. Okay, so forward 7, down 5 would look like this, right? Yep. How long is it going to be? 49 plus 25. Remember, when you square a negative, it becomes positive. The Pythagorean theorem, a squared plus b squared, is always going to be an addition. All right? So, what is that, 74? So the magnitude of PQ is the square root of 74. The hypotenuse, C, is the square root of 74. All right, one more, do it all by yourself. All right, so see if you can find if you want the coordinates or the components and the magnitude.
Negative.
Let's find both of those things.
Wait, is it subtract? Subtract.
We're going from -2 to +6. -2 to +6. How many steps is that? That's 8, right? -2 to +6. Kids, I don't know. I don't. Get out your number line if you have to. We're at -2 to +6. Count the number of steps if that's what you need to do. You shouldn't need to do that. You should be able to figure that out. But if you can't, okay. But don't sit there and get all confused. Do this. You're going to have to do this for every single one of them. Okay? -2 to +6 is 8. You can figure that out if you just take a minute and think. Now, what about from 4 to 1?
Negative.
That one's -3. You got to remember the negative, because if you're starting at 4 and going to 1, you're backing up. So your movement is negative. Now, what is the magnitude of that vector? Well, go over 8 and down 3. So the Pythagorean theorem would say 64 plus 9. Remember, it's always add because that squares out, that negative squares out. So this one is the square root of 73.
I drew the triangle differently. I went down 3 because of the y-axis and then connected
Okay,
it.
we gotta draw, don't do that. We draw the butterfly bow tie. always the butterfly bow tie.
Do we have
And it won't matter for magnitude, Max, but in a little bit we'll be talking about the direction angle, and then it will matter. So get in the habit of always drawing the butterfly bow tie.
do we have to draw the picture?
No, because hopefully after doing these 4 problems, you have noticed that to find the magnitude, all I did was square that number and square that number every time. That's what happens.
Okay.
So if you need to visualize it, it's kind of like the number line. If you need that, then you're going to do that. But you don't have to, because every single time you find the magnitude, that's going to be the x, and or like the a, and that's going to be the b, and you're going to square them, add them up, and square root. So you don't need to draw the triangle. Now, again, if you were listening to the conversation I was having with Max, when we get to the second piece of it, which is the direction angle for the vector, then you will need to draw the picture. But if all you need is the magnitude, doesn't matter, you don't need it. Okay, page 1, let's go to page 2. Now, this is exactly the same kind of thing, except the coordinates of the vector have already been given. So in other words, this is a vector. This is not point P. This is already a vector. This is a vector that goes back 3 and up 1. And this is a vector that goes nowhere sideways but up 3. Oh, no, that's W, sorry. V is 2, -2. So now we've got 3 vectors, and we're going to do some operations with them. This is the equivalent of page 2 of your last test, where I gave you some matrices and you did stuff with them. Well, now I've given you some vectors and you're going to do stuff with them. Pretty easy. A says U plus V. Now, U plus V. Here are U and V. Take a wild guess, just random guess, what U plus V would be. -1, -1. If that's what you said, you're right. Because to find the sum of 2 vectors, we add the x's and we add the y's. Exactly. Because let me show you something. Look at this. A matrix is nothing but a bunch of vectors stuck together. So everything we do with matrices is pretty much duplicated somewhere with vectors. Good observation. Okay, next. V, 3V. 3 is called a scalar. We are multiplying a scalar, a number, times a vector. What do you think the answer will be for 3V? 6, -6. Oh my gosh. That's another one of those. If you miss it, it's hopeless. If you want to multiply a number times a vector, you just distribute it, just like you do with a matrix. All right, we talked about this one. What did I tell you that notation always means? Magnitude. That's the length. And I could draw a picture of vector U. I could draw a picture of that, but somebody observed I really don't need to draw a picture of it, because one side is going to be 3 and the other side is going to be 1, and so when I do the Pythagorean theorem, I get the square root of 9 plus 1, or the square root of 10. When you find the magnitude of a vector, remember, this vector would look like this. This is one side, this is the other side. So you're just going to square those, add them up, and take the square root. That's going to be your magnitude. U plus 2V. So that's -3,1 plus 2 times 2 -2. Doesn't that look just like a question on your test? Except they were matrices, now they're vectors. So what's the first thing you think we're going to need to do here? You're going to distribute that scalar, so this is going to be 4, negative 4.
So that's still called a scalar?
Yes.
Okay.
And then we'll add them. And that will be 1, comma, negative 3. V minus W. So 2, negative 2 minus 0, 3. Now we're doing a minus problem. No big deal. We're going to subtract, right? So what do we come up with? 2 minus 0 is 2. Negative 2 minus 3, negative 5. There's your answer. F. The opposite of U, or negative U. The opposite of U. Well, what would the opposite of U be? 3, negative 1. This stuff is so easy. All right, G. Now be careful. The order of operations here is you got to do what's inside first. So you can think about that absolute value as kind of like parentheses. You got to do what's in there first. And then we'll take the magnitude. But first, we got to do U minus V. Okay, so what's U minus V going to be? U minus V. Negative 5. 3. So U minus V is negative 5, 3. Negative 3 minus 2, 1 minus negative 2. Is that okay? Now, to find the magnitude, if you want to draw a picture of that, you can, but one side's going to be 5 and one side's going to be 3. So the answer is going to be the square root of 25 plus 9, which is the square root of 34. This is not hard. We should be able to do this. Last one. 2U plus W inside absolute value. That means magnitude. So we need the magnitude of 2U plus W. Okay? So the first thing we probably got to do is figure out what 2U is. So 2U would be negative 6, 2. Now we're going to add that to W. So negative 6, 2 plus W is going to give me negative 6, 5.
And then you do it. And you find that you're done.
Right? And now I need the magnitude of that.
81.
So it's going to be the square root of 36 plus 25, which is what? The square root of 61? Okay? All right. By the way, I have another vocabulary word for you. A new vocabulary word for you is resultant. I can't remember. Do I have any physics students in this class? None? A resultant is the sum of two or more vectors. So if you have a question in the homework or on a quiz that says, find the resultant of U and V, what that means is add them together. Resultant means sum. Sum means add. So if you want the resultant of two vectors, you add them together. In the real world, this happens all the time. When you get in an airplane, and your airplane is flying on this course, but the wind is blowing, how you actually go is the sum of those two vectors. That's why your pilot or your navigator does not, if you want to get from point A to point B, he doesn't point you straight at point B. Because if the wind is blowing, he has to point you a little bit this way so the wind will push you back to point B. That's the resultant of the two vectors, the plane and the wind coming together. Same thing happens to you like when you ride your bike. When you're out riding your bike on a windy day, what happens to you? Does it tend to push you one way or the other? Well, no, because you're so powerful, I know, but yeah. Okay. All right. Number 5. Number 5. A unit vector is a vector whose magnitude is 1. So a unit vector has a magnitude of 1. So a unit vector is a vector that when you do the Pythagorean theorem, you get 1. We haven't found any of those yet. Ours have all been things like the square root of 74 and that kind of stuff. So here's how you do it. This will absolutely be a quiz question. Absolutely. So take whatever notes you need to so you can remember how to do this. It's very simple. Step 1. Find out how long the vector is that you have. So they've given me this vector v. It is not a unit vector because its magnitude is what? It's 4 plus 1, it's the square root of 5. So the magnitude of this vector is the square root of 5. To make it a unit vector, all you do is take these two numbers, negative 2 and 1, and divide them by the magnitude. So your unit vector is the same as the original, except it's over the magnitude. Now wait a minute, did we do anything in matrix land where we took some numbers and put them all over something? This is like doing the inverse, only instead of dividing by the determinant, you divide by the magnitude. So when I look at B, which is 6, 2, what is the magnitude? Oh, by the way, you do not need to rationalize. You may leave the radical in the denominator.
Always or just in this one?
No. Always you can leave the radical in the denominator. Now this one's going to require some simplification, but you can leave the radical down there. What?
I don't know if I missed this or what, but for the arrow that you're putting on top, are you purposely putting one line?
Yes, because this is not a ray. In geometry, you use this symbol. That's a ray.
Okay.
So tell me about that. Tell me about ray AB. What does it look like? What does it do?
I didn't have geometry.
You didn't pass geometry.
I don't know.
Okay. All right, let's say this is point A and this is point B. When I draw ray AB, it does this.
Yeah.
It goes on forever. Rays go on forever in one direction. Vectors do not. They have magnitude. They have length. So ray AB starts out the same way, but it stops at B. It doesn't keep going. Right? So sometimes people use the ray symbol on top of vectors. If I'm in pre-calculus class and this is the vector chapter, then I'm going to assume they're all vectors. But if I'm just reading a general math, article, I need to know whether I'm talking about vector AB or ray AB because they're very different. Ray AB includes all these points. Vector AB does not. Okay, so where am I? I'm now here. This is a negative. All right. So I have the Vector 6, -2. Step 1, find its magnitude. I'm going to make it a unit vector, but I can't do that till I find its magnitude. So the magnitude will be 36 plus 4, square rooted. So that's the square root of 40, which is 2 root 10. So your teacher told you that if you want a unit vector, you need to take the original two numbers, 6 and -2, and divide them by the magnitude. Now, this is not okay. Now, the 10 is fine, the root 10 is fine, but you have a 6 over a 2, so that's 3 over root 10, and this is -1 over root 10. So you are expected to reduce your fractions, but you do not have to rationalize. That is, get rid of the radical. Okay? All right. Now, the next one is, looks different, but do not be afraid. Okay? It is done the same way. Okay? Here we go. Magnitude. Square root of 0 plus 16. So square root of 16, which is 4. And if you think about that, it makes sense. Because if I draw the vector 0, 4, doesn't it do this? Doesn't it start here and go straight up 4? So how long is it? 4?
Why is it not plus or minus?
Magnitude is always positive. Yeah, we haven't plus or minus any of these. It's always positive. Now, once I find the magnitude, I go back to my original vector, which is 0, 4, right? And I divide those by 4?
0, 1.
So my unit vector for problem C is 0, 1. That's my unit vector for problem C. 4 over 4. 0 over 4 is 0, and 4 over 4 is 1. All right, try the last one on your own. See if you can find the unit vector for -3, -4. Find the unit vector for -3, -4. Does everyone remember what step 1 is? Step 1 is find the magnitude.
Where's the one?
I know.
Where you said a unit vector before? What does that have to do?
If you find the length of any of these vectors that you said are unit vectors, the length will be 1. If you square out on square root, you get 1. They're all 1 unit long.
Wow.
Now, what was the magnitude of this guy?
5.
5. The square root of 25, which is 5. So your unit vector was -3/5, -4/5. And Shelly's back there saying, well, where's the 1 come from? Look, if I said find the magnitude of this vector right here, you would square that and get 9/25. You would square that and get 16/25. And you would add them together and take the square root. What's 9 plus 16? 25. 25/25 is 1, and the square root of 1 is 1. The length of this new vector that you find will always be 1. Now, what's so special about 1s? Well, I can't tell you yet. Well, actually, I sort of can. Sine squared plus cosine squared equals 1, right? So that's part of it. Okay, that's what's so special about 1. Because you're going to learn that this is really a sine and a cosine. You're going to learn that shortly. All right, speaking of which, now we're ready for number 6. Huh? Okay, go 10 minutes. Yes. This is the day the Lord has made. Let us rejoice and be glad. Which was our prayer this morning. And
attitude is 80%, circumstances 20%.
And I loved what he said at the end, that this is the day the Lord has made. Let us be thankful, or something like that. He said that was pretty neat. Okay. Now, let's come back. This was some vector in the last problem. This was called its component, or these were called its components. This is an X and a Y, right? I graphed a few of them. I said, okay, if I graph this one's going to look like this, right? Over 3, down 4. These are the components. When we talk about the components, we're talking about X and Y. So now I have this picture, which does not have an X and a Y identified, but would you agree that there is an X here and a Y here?
Let's imagine.
So now I have to figure out what that X and Y are. So I'm going to think about SOHCAHTOA. Because using 37 as my angle, this is the opposite, this is the adjacent, and this is the hypotenuse. So thinking about SOHCAHTOA, sine of 37 should equal what? Y over 16? Opposite over hypotenuse? This is not new. This was on a test you took. I mean, it wasn't talking about vectors. Y over 16? So how can I find my Y coordinate? James is digging for his calculator. He's got the idea. 16 sine 37. So I'm going to type 16 sine 37. 9.63 today says. And we'll agree or disagree. Is that okay? 9.63? Yep. And we're looking for both of them. Doesn't matter which one I start with. So cosine 37 equals X over 16. So sine will help me find Y, and cosine will help me find X, because Y is opposite and X is adjacent. I'm not using tangent because tangent is Y over X, and I don't do either one of them. So I'm always going to use either sine or cosine. So here we go. X equals 16 cosine 37. So what is my X value? 12.78. Now, just like on the test you just took, this must be written as an ordered pair. The coordinates of the vector are 12.78, comma, 9.63, and they have to be in that order, X, comma, Y.
Wait, can you explain the why it's not tangent again? But if you have the opposite though, so
But we don't. We rounded it off. We never use rounded off numbers if we can help them.
So you just use.
You gotta use the 16. You gotta use the 16. It's the only one that rounded off. Okay. Now we get to one that's a little bit trickier, but not much. This is 10, this is 40. This is X, and this is Y.
One's gonna be, they're gonna be negative.
X is going to be negative. Shelly just got the tricky part. I am going to type into my calculator cosine 40 equals X over 10.
Negative X.
And then I'll do 10 cosine 40 equals X. And that will give me this number. But because I'm sitting in quadrant 2, I have to make sure that I make that negative. So I'll type that into my calculator, and it will say 10 cosine 40. 7.66. But because of where it is, this way, it's negative 7.66. Does that make sense to everybody? Now, will I have to worry about that with my sign, with my Y value? No, because it's going up, so it's fine. So 10 sine 40 will be my Y value. And what is it? 6.43. So this is one of those times when having the picture can really be an aid to you so that you get things signed right, S-I-G-N-E-D. All right, let's try this one. So this is 8, this is 31, this is Y, this is X. Now, can you tell right now, since we just talked about it, we're going to have both a negative X and a negative Y? So you can mark it right now, you can wait till later, it doesn't make any difference, they're both negative. Because you went left and down. So, X is going to be 8 cosine 31, and Y is going to be 8 sine 31. Now, I kind of skipped a step, I skipped the setup step. Is that okay with you? If it's not, go ahead and write it down. Cosine 31 equals X over 8. Cosine 31 equals adjacent over hypotenuse. So X equals 8 cosine. Y equals 8 sine. X is always going to go with cosine. Y is always going to go with sine. Always, always, always. So we type them in. We're going to get some decimals. We've already made them negative. James?
For negative 4.12.
Negative 4.12.
And negative 6.86.
Are those in the right order? Would somebody type 8 cosine 31 for me? So he's got it turned around. So 6.86, and what was the other one? 4.31? No. 4.12. All right. Let's do that last one on your own, and we'll check it, and we'll be done for today.
What if I just smack you out on your
Okay, guys, you're supposed to be doing the problem. Our whole conversation is being captured on video. I would prefer that it had something to do with math. We had problems back in chapter 4 where we always had to worry about those negatives. And we're still there, we still have to worry about negatives. Will anything be negative in this problem? The Y will be negative. You need to pay attention to which quadrant you are in. Remember, unless you're in quadrant 1, something will be negative. Remember me saying that? So unless we're in quadrant 1, something will be negative. Okay, so cosine 15 equals x over 100, and sine 15 equals y over 100. So 100 cosine 15 equals x, and 100 sine 15 equals y. Anybody come up with those numbers yet?
28.88.
Is x 28.88, and that's a positive number. Are we sure?
No.
That's not right.
Okay, guys, we should not be having issues. Type 100 cosine 15.
96.59.
96.59. Now the other one might be 28. It's type 100 sine 15.
25.88.
25.88. And that one is negative. There is no sympathy for getting them turned around. X goes with cosine, y goes with sine. Always in